It's still Thursday. I'm actually going to go ahead and just do one example. My printer does not work, so I hand wrote this word problem here. So let's do one word problem and then you can work on your homework. All right, so a ball is shot upward from a 60-foot platform at an initial velocity of 64 feet per second. About how many seconds does it take the ball to land on a ledge 43 feet above the ground? So I just wanted to bring back, so we don't forget how to write those projectile motion problems. So don't forget, when you have something that is launched or dropped or whatever and it's having gravity act upon it, it's going to be that negative 16t squared. And then initial velocity of 64 feet, so plus 64t. And then it's launched from 60 feet up, so plus 60. Okay, that is your equation. Then we have a couple different things we could do. We could either find the vertex, which would tell us the highest the ball reaches, or we could solve for the zeros and see when the ball hits the ground. In this one, we're actually saying when does it hit a 43-foot ledge. So instead of setting it equal to 0, I'm going to set it equal to 43. Okay, and then, whoa. And then from there, you could do whatever you wanted to. We've now learned pretty much every method, but this is probably not going to have rational answers, just given the fact that it's a time problem. So we're going to go ahead and do quadratic formula. So I'm going to go ahead and move this 43 over so that I can get it set equal to 0. And then that's going to be 17. All right, and then A, B, and C. A is negative 16, B is 64, C is 17. So x equals negative 64 plus or minus square root 64 squared minus 4 times A times C all over 2 times A. Okay, that's a little bit close, I apologize, but whatever, there's this line. Okay, so x equals negative 64 plus or minus square root, and then I went ahead and did this beforehand and got 5184 on the inside there. Okay, move it again here. Okay, over negative 32. All right, this does tell me that I'm going to have two distinct real answers, and if you actually square root this guy, he actually is a perfect square. So he is going to be x equals negative 64 plus minus root 51 is 72. Okay, and I think I just misspoke earlier and said there was no rational answers. This ends up actually, it does have a rational answer. I was just looking at my answer as approximate decimal. But either way, it does have two distinct answers, and because it's a perfect square, they are nice answers. There's no radically things going on. All right, and then we are going to take and do our positive route and our negative route. Positive route, we're going to keep the plus sign. Negative route, we keep the negative sign. Okay. All right, when you do that, you're going to get positive 8 over negative 32. So that's negative 1/4. Okay. Over here, you're going to get, I'm just looking at my number, negative 136. You're going to get negative 136 over negative 32. And that is 17/4 apparently, which is 4.25. Okay, sorry, I'm not doing great. Okay, so these are our two answers, which means if I went back in time a quarter second, then it would be at 43 feet, but that doesn't make any sense in real life, so we don't use the negative answer. So 4.25 is my answer. So the ball is landing on a 43-foot ledge or whatever at 4.25 seconds. So I just want to make sure you guys, this is not a very great video, but I'm not recording it again. I want to make sure you guys can just see how a word problem works. Make sure you don't forget that negative 16t squared plus the velocity t plus initial height. And then now that we have the quadratic formula, we are able to solve literally anything, and we can get basically whatever we want to for answers. I am just going to go ahead and do one example, but I do recommend looking at the 8-7 day 2 notes and looking at examples 5, 6, and 7. Those have some more decimally answers, so you can see how that works out. All right, see you guys tomorrow. Bye.